Assalamualaikum, my name is Muhammad Al-Ain bin Mazin. Today I will like to present about my bachelor degree project, which is validation of geotube material structure and the static and environmental effect. So, I will with my supervisor, Dr. Muhammad Aimullah bin Abdullah, to complete this project. Let's look more about detail this project by part. So, let's continue the abstract part. So, abstract part include about introduction, methodology of this project, result and discussion, and conclusion of this project. So, in the abstract, this study was conducted to make observation on the material that has been provided in collaboration with my tank, Industrial Sdn Bhd to ensure mechanical properties replacing the dewatering method with the proposed material because nowadays geotextile tube have contributed a lot of control the worsening coated erosion. To ensure the objective of this research runs smoothly, that is to know the mechanical properties of the material as a comparison, make observation on the porosity between two materials, and see the permeability with the purpose of geotextile tube structure application. The scope of the study was conducted using material data from Tenkata Geosynthetic Asia Sendirian Berhad as a reference and obtain information on mechanical properties by using universal tensile machines. To conduct this study, several methods have been used with certain standard procedures such as tensile test with ASTM E4 standard test, porosity test for penetrate two different types of polypropylene, and permeability with sieving and sealing method as a test for a given material that is Malaysia. This study used three different materials namely Malaysia polypropylene, China polypropylene, and linear low density polyethylene LLDPE. Based on the observed data, both elongation and stress strain graph data were obtained for latitude and longitude as a comparison to China PP and standard besides being able to take porosity data comparing between Malaysia polypropylene and China polypropylene. But for low linear density polyethylene, what is observed is which method is better between seals or sealing. My tank can use polypropylene from China for geotube application, and low linear density polyethylene can replace the standard polypropylene material geotube structure because dewatering process is not necessary since the linear low density polyethylene material can withstand the liquid for long period. Now, let's move on into introduction. Introduction used to give more detail about this project. My tank gives three materials with its Malaysia polypropylene, China polypropylene, and linear low density polyethylene. They give this material to change the current material which is GT750 with their material. They also suggest the new method with is withstand the water in and solid without dewatering process. What is dewatering process? Dewatering process is to eliminate water from filling process. So let's continue about objective of this study. Objective this study is to conduct a tensile test for different type of polypropylene material and extracting the mechanical properties for comparison purpose. Second, to study the effect porosity of polypropylene between Malaysia and China materials. Third, to observe permeability of linear low density polyethylene material for geotextile tube structure application. Now, let's look the simple literature review with relationship this project. First, the geotextile tube have contributed a lot to control the worsening cost erosion using polypropylene weaving with a tensile length in the range of 100 kN per meter up to 200 kN per meter, indicating that this weaving is high strength. Second, the process of using this geotextile tube is using the dewatering process. Third, Third, dewatering process is method of separation between solid and water using geotextile, a filter medium for two different mediums in the sludge. Fourth, LLDPE, which is linear low density polyethylene, is derived from the copolymerization of ethylene with a longer olefin chain. LLDPE is mostly used as plastic base, stress, wax, and pots. Polypropylene is polymer that is catalyzed from polypropylene. Polypropylene is also a color-free material and it is better than polyethylene. Structure of this polypropylene is of the olefin monomer polypropylene. Methodology. Methodology used to give detail how this project conduct. We start with my flimsy tank, give their sample with is polypropylene from China, polypropylene from Malaysia, and linear low density polyethylene. We divide into two tests, which is mechanical test and environment experiment. For mechanical test, we conduct with tensile test of two polypropylene material from China and Malaysia. Because China polypropylene we get data from Huai Heng company, we not do China PP test. We only do Malaysia PP test with is divide into two tests, longitude and latitude test. For each test, three samples will be tested in tensile test. After the test, we can get the data from mechanical properties analysis. The data we get which is force elongation graph, stress strain graph, and its strength and maximum its strength. Now we look into environment experiment. Environment experiment we divide into two tests with porosity test of polypropylene and permeability test of linear low density polyethylene. For porosity test of polypropylene, we conduct we put the water into Malaysia and China PP to look whether the water flow out or not. The test conduct 12 hours. For 1 hour data will be recorded. Permeability conduct to look with method suitable to make sure water not flow out. The test do by day by day. The test will do day by day, and if no water flow out, it continue week by week. Two methods we want compare is sieving method and heat seal method. Data will record, and lastly report writing will do for complete this project. Now we move into result and discussion for tensile test. The table shows the comparison between Malaysia PP, China PP, and standard GT750 polypropylene from Tenkata. This table will prove that the material made by Malaysia is suitable or the same standard as China and GT750. This table shows the size testing used, the number of feet, latitude and longitude, tensile force, and percentage of broken elongation. The size used by Malaysia PP and China PP is according to the standard for tensile test. The number of threads for the size test for latitude and longitude followed the standard of 88 to 58 for 10 cm for China PP, which was 52 for both latitude and longitude, while Malaysia only follows the standard for longitude, which is 53, but latitude is 44, less than China and the standard. To ensure that the given material can be used in Geotube textile application, the longitude tensile force must exceed 1,600 Newton, while the latitude is 1,800 Newton. The tensile test conduct look for Malaysia PP and China PP does not exceed the standard when Malaysia PP only get 937.52 Newton for longitude and latitude is 866.91 Newton. For China PP, the tensile force obtained is 1082 Newton. Standard broken elongation for longitude and latitude is more than 15 mm. Malaysia PP test show that broken elongation is less, namely longitude 2.40 mm while latitude is 7.24 mm. From the data obtained shows my flexiting for Malaysia PP does not follow the standard and is not suitable for Geotube textile unless it will be improved. For porosity test, the tables show the comparative data between polypropylene Malaysia and polypropylene China. From the data obtained shows that Malaysia PP has a porosity that causes water to pass through the pores compared to the China PP. The amount of water that passes through the pores of Malaysia PP is 0.02 liters until the experiment period of 12 hours is complete. The probability of water flowing in the pores is likely due to the pressure applied while conducting the experiment, so as to cause the structure to disintegrate. This proves that this Malaysia PP material is not suitable to be applied as a second layer material of geotube textile compared to China PP because my tank wants to maintain a water and solid solution. For permeability test, you can see the figure shows the difference between weight of bag seals by sieving method first and weight of bags sealed by heat sealing method. The weight of bag decreased gradually every day after being measured for the sieving method. Meanwhile, the weight of the bag remains stagnant and show any change throughout the 2 months period for the heat seal method. The situation can be detected as the sieving method cannot contain water inside the LLDPE bag because of the small pores created between the swing part and the LLDPE material. The small particle of water managed to escape the pores created from swing part but not through the material itself, as the leak was spotted only in the area of swing part. The deduction can be supported with the fact that by using heat sealing method, there was no leakage observed as the seat part and also the entire base were dry even after 2 months of exposing it under the sunlight. For the conclusion, Malaysia PP proposed by my Flexiting showed that a given material does not follow the property standard and is not suitable for use in Geotube textile application compared to China PP which meets the property standard criteria. The second is China PP suitable for use as a second layer if the first layer of LLDPE and myflexiting can use PP from China because PP from Malaysia with has low tensile properties. LLDPE can replace the standard PP material from Tenkata Sendian Berhad, namely GT750 for geotube structure. The watering process is not necessary since the LLDPE material can withstand the liquid for long period. My tank can save more cost in use this new method than dewatering process and this method can save more time. So this is some reference that used to complete this project. I would like to thank to University Tun Hussein On Malaysia, Faculty of Engineering Technology and Supervisor for helping me throughout this work by providing facilities in terms of access to information relatively and providing ideas for improvement. I would like to thank my Flexitank for collaboration with UTHM to research about Geotube under UTHM Industrial Drone M039. So that's all from me for my presentation. Thank you very much.